So I don't know. Thanks for spending time.
Thank you. Nice to be here.
This will be fun. I don't know. I feel like there's so many things we can talk about. I feel like one of the things we should talk first about is maybe just a little bit about Einstein and all the things that you've learned in the last year.
Einstein. Sure. Einstein is a very deep word, as deep learning. So basically, it's a AI layer, AI platforms on top of everything in Salesforce. So Salesforce, we have sales, service, marketing, commerce, IoT, analytics, productivities, and basically anything relating to customers. And we want to make all of them intelligent. One way to do it is every single product unit, you can hire 100 data scientists, PhD, to work on it. The other way to work on it is to have a platform capability to enable developments of AIs and all this. So Einstein represents the product's capability to bring to customers. It also represents the technologies and the platforms that we have in Salesforce.
And so, you know, when we were talking last week, we talked a little bit about some of the misconceptions right now that people have as they talk about AI. And I think one of them is this idea that it is just hype, right? That's a misconception. Another one is that it's a magic bullet, which is also a misconception. And I wonder, when you think about the heart of AI, what do you actually think about?
Yeah, I don't think that's like misconceptions. AI has been around for 50 years, right? Or more than that. At the beginning, AIs, people think about it is, oh, how can I simulate human with technology, with algorithms? How can I create a robot that simulate James to do investment, for example? That's
very easily.
Yeah,
dartboard.
Yeah, just randomly pick something. Anything end with .ai, we invest in it, right? That's part.
Yeah, double the price.
Okay, yes. So that's the outdated definitions. In recent years, the reason why people are thinking about, oh, AI is a new wave, we can apply to it, is thanks to a number of technological breakthroughs in big data, in storage, in distributed processing, in deep learning, the capability of machines that can help humans becomes more and more powerful. And at least in Salesforce, and I can see in other startups and business as well, the way they apply AI is no longer trying to replicate human to like maybe play table tennis, or well, there's some PR effort to say, hey, we can play Go or play chess like that. But a lot of the applications is really about augmentations. How do you enable people's life, make them more powerful? And so I think that's the direction of AI. It's not about like last year is hype, this year is reality. We're always in the fantasy that AI will change the world. But whenever there's new technologies comes in, like personalization, newsfeed, predicting what you like to see, in the past we call them intelligence feed, we call them AI. But once they become reality, no one call them AI anymore.
Yeah, you know, I'm really interested in general around how building artificial intelligence is different than traditional software development. And I think this is actually poorly understood by almost everyone who has not actually built a model. So tell me a little bit about how that process is different.
Right, so James, you mentioned about model. What is a model?
You know, so a model, so depending on what you're talking about, I think what's interesting is people will conflate, when I say model, I think people right now conflate this word algorithm, and they use it in many different ways. And I think oftentimes what they will mean is they will talk about this derived program that comes from another program that took in a bunch of data to derive this other program. And I think what's interesting is like that at its core is actually different from what most people have been building for many years.
Yeah, so that's definitely great definitions. Like
I stole it from Peter Norvig, by the way,
right.
So there's mine.
I'm glad I didn't say this wrong. So, so we have a lot of terminologies in this space. First, we say AI, and then like 2 years back, 3 years back, we say machine learning. Everyone, including myself, pitched to investors, say, hey, we're a machine learning company. In fact, we are. And then people say, hey, deep learning. We trump machine learning. No one uses machine learning anymore. You're doing machine learning, we're doing deep learning. We're better. Next year, 2 years later, people will say we have deeper learning, deepest learning. The reality is machine learning is the technology that enable AI. So you mentioned about learning from data. Learning is a big piece in AI developments. So why the system can be intelligent? why the system can be intelligent and simulate or empower us, become better than us, even predict the future. It's because as you feed it in with data, good data, and then algorithms that can learn from the data, you get good results. So learning is the key word, which makes it super different from traditional software development.
Both,
learning.
And critically, it is probabilistic, and it is very hard to QA and understand.
Exactly. So learning means things are changing. You create web applications or iOS applications, wherever it is. You publish it to the app stores. You don't need to change it until you have a new version. Modeling, AI, learning is different. You learn from new data every minute, every day. So you change the model, and it is difficult to explain what the change is because it's from data that you have collected. So how do you do QA? How do you monitor it? How do you prevent bias? You guys have heard a lot of things about the AI model has learned something that the original creator does not intend it to learn. So that's the challenge of creating AI.
And I think that this understanding is actually is a key thing that people outside the industry or outside of practitioners don't actually get. And what is interesting to me is that because it is different, I believe that machine learning-led companies will actually have different economic characteristics than traditional software companies. And as people talk about the revolution in AI, so often they talk about interesting technology advances. I think the actual secret key and the way to make a huge amount of money is for someone to be like Bill Gates or Mark Benioff, which is to say people who understood the economic characteristics of a new technology and then sold it in a different way and provided a different business model. So the idea that you should give me all your data and stick it in my server is crazy. And the fact that Mark Benioff convinced the world that that was the way to work is an amazing feat. The idea that software should be something that you pay for is also crazy. Like in the 50s, people would get software for free and they'd make customizations that they would pay for. And the idea that you would actually pay for it was actually both a marketing and product revolution, and there was an incredible amount of value created there. And I think that there's something like that for AI, but I have no idea what it is, but I'm hoping Simon will tell me what it is right now.
Well, that's $1 million question. So
I think it's $1 trillion question.
$1 trillion questions. I don't have the perfect answer, but I can share my experience running a number of companies in the past, many of them using AI or like intelligent system to enable or enhance customers' experience. The last one, Prediction.io, got acquired by Salesforce. It was a software development platform, machine learning server that enabled developers to build smarter applications easily. The biggest challenge I saw was two things. One is data, and I think it changed the way how startups compete with large incumbents as well. Like in the past, startup, you guys do the sprint faster, you have lean developments, you move faster, you build products faster, you do everything faster. You have all the advantages to disrupt the industry. But when it comes to AI though, problem is where is the data? Like you mentioned about it, like Salesforce, we have 100,000 customers. Data is here. True that we don't own the data, trust is #1 priority, but still, like if the customers allow us to do it, we have access to the data.
It's fascinating because as you talk to all of the big companies out there right now, they are all convinced that they are the definite winner of the AI war. And they're all convinced that there's no hope for any startup. And I think they're probably wrong. I hope. I'm a venture capitalist, so like that's part of my job. But
well,
what are the opportunities?
At least in Salesforce, our goal is not to kill every startup in the world, right? That's not part of our mission statement, I believe, as far as I know. But hey, we have App Exchange. We're a platform as well. Startups, you can create applications on our platforms. Our customers, data already in Salesforce, they can access to your AI technologies, to your applications with just one click. I hope it's one click, not two.
Is it one click now, or is it
through the App Exchange launch? Yeah, so the platform strategy becomes super important for large companies to compete with each other because hey, you have all the data, but you don't have all the talents and applications idea in the world. The second piece that I actually related to the question is, I think like data is very important. The second thing is industry. One challenge I find when we were serving customers at Prediction.io is every prediction problem is unique. It is unique because your data is unique, because your industry is unique. And even if you're in the same industry, think about the most classic one, product recommendations. Netflix product recommendations, the goal is not to sell more movies, is to extend the subscriptions. And Macy's, the recommendations may not be to maximize the revenue. Maybe it's to sell the products that no one buy. So every business unit, maybe even in every sections in your business website or emails, they have different goals. So now you need to teach the computer, you need to optimize for multiple goals, and you need to understand it. So challenge is, when we were creating prediction now, we want to make it generic. We would say, hey, if you don't need a specialist to do database search, then why do you need a specialist team to do machine learning? So we created a machine learning server. But it turns out that we find that it's extremely difficult to have a generic solution for every industry. But that's why you take the open source approach, but it's very different.
I think you've captured one of the key insights that's poorly understood right now. That typically, in part because we think of AI and we think of a brain, we think brains are multi-purpose, and we think that every model that gets created, there'll be some magic big model that'll solve everything for us. That might happen one day because there are various researchers who have clever ideas about it. But the reality of today is that there need to be a lot of small models and a lot of mixed models in order to make better decisions. And so one of the questions we ask a lot is, what are the economic implications of machine learning? Not from the point of view of, oh, I'm going to lose my job, but more from the point of view of how do you think about machine learning from a microeconomic point of view? And the best thinkers that I've seen talk about it. So we talk to all the consultants, they're all idiots. We talk, no one really knows because very few people are still practitioners or have been working long enough at it. And so the best people that I've seen talk about it are these three guys out in Toronto, these business school guys, who've said that the atomic unit is to think about the cost of prediction. And when the cost of prediction goes down from a microeconomic point of view, what are the complements and the substitutes? And when the cost of prediction goes down, then what's really interesting is that judgment becomes more valuable, meaning what are the questions that you're asking? And so suddenly, when you're able now to ask many, many more questions, you can create lots of interesting value.
Yeah, basically the general AI and narrow AI is a big debate in all these years. And people usually switch between the two. Sometimes we say, hey, machine can go general, and sometimes we say, hey, no, we need to specify it in one areas. Hey, James, so I want to ask you, actually, we as entrepreneurs, startups, we create our applications. We think we have the best talents in the world. We think we have the best technologies. So when we all pitch to investors, we say, hey, we have the best technology, we have the best team. How do you measure it? We talk about it's difficult to, it's different from software development cycle, right? How do you tell?
Right, so it's totally true. 4 years ago or 3 years ago, what it took was as an investor, I'm just looking for signals of quality. I'm looking for something that's special in some way. And 3 or 4 years ago, all you had to do was be competent at it and be able to build it, because actually building it is really hard, right? I mean, that's why they acquired you. But now, in part because platforms are available and you've released a bunch of stuff open source, that means the bar is much higher. And in some ways, my old signal of quality, which is you got a PhD, you worked on these things, you implemented these processes, that's no longer a signal of quality. That just means you're like everyone else. And what is surprising to me right now is that there's not that much variation in business models. That actually, everyone just tells me we are a better version of some software application. And I think that misses a huge opportunity. And I think, at least to me, that's the interesting opportunity. That's what I look for.
But where's the opportunity? What directions? Where's the gold mine? Is it platform strategy? Is it disrupting traditional industry with data? Where's the next big thing?
So, I think that right now we have not thought clearly enough about what it means to deploy and work with models. And I think in the same way that building software, there are thousands of companies and billions of dollars to help people make software. Right, hundreds of billions, right? If you were to add up all the money that will be spent on helping people build models in the next 20 years, that'll be also hundreds of billions of dollars. And it'll be all sorts of boring small things that you deal with now in some small way, but when there are thousands of models that you're building, or tens of thousands, suddenly you worry about it differently. And so that kind of scale and need for productivity is very interesting to us. So if you, we talk about that all the time. The other one is that it is true that the big SaaS providers, who are wonderful and for whom we are all very grateful, because this space is amazing, but a lot of what they care about and a lot of what they've done is convince people that your data is safe. But when it's safe, it's also closed off. When it's closed off, it's much harder to do cross-learning. And that's an opportunity for lots of small companies to be little wedges, just to offer a slightly better piece of advice, a slightly better perspective, and from there, maybe eventually, after many, many years, compete with the big players.
That's a very interesting positioning. The untrusted nature of startups' products now becomes an advantage when it comes to data access.
I, of course, wouldn't call it untrusted. But
I have to call it untrusted because trust is the #1 value in Salesforce.
Right, that's right. But with that, we're out of time. Thank you so much for paying some attention to us.
Thanks, we'll have more talk at the back.